Hello everyone, welcome back to our channel, and in this today video lecture we are going to discuss about Arrhenius theory of ionization, which assumption and the failure of Arrhenius theory of ionization, which is in electrochemistry of BSc third year basically, but it has to be studied in class from class 12 as well. Okay, so let's discuss it. And let's discuss the first assumption. So we know that ionization and dissociation are the different factors. So ionization means the formation of ion in the electrolytic solution, but the dissociation is dissociation of already present ion in the electrolytic solution, right? So there are some assumption of Arrhenius theory of ionization. So for the first assumption is in electrolytic solutions they dissociate into their respective ion. The positive ion is called cation and the negative ion is called anion, and the charge between positive ion and the negative ion is equal. The charge of positive ion is equal to charge of negative ion. That's why any electrolytic solution is neutral. Okay, so the second is when electricity is passed to the electrolytic solution, the cation move to the cathode. That means cathode is negatively charged electrode and cation is positively. So positive and negative will be attract each other, and anion will move to anode. Okay, this is the basic concept of electrochemistry. And also it states that in course of moving or dissociating, mainly dissociating electrolytic solution, the dissociation is inversely equal to the association also. Okay, when AB will dissociate into A plus and B plus B minus, and it will again reunite and form AB. This is the state of equilibrium. Okay, so I have to write like that. You have to write like that. Okay, so the next assumption is electrical conductivity, which electrical conductivity is depend upon the number of ion present in the solution, and the number of ion present in the solution means degree of ionization, and the degree of ionization is directly proportional to the nature of electrolyte. That means weak electrolyte, it is weak, then it has less number of ion present in the solution, and if it is strong electrolyte, then it has more number of ions present in the solution, right? So this is the fourth assumption, and the fifth assumption is in fifth and first assumption are nearly equal, nearly same. So electrolyte is neutral until electricity passed, right? Electrolyte neutral until electricity passed. That means there is no dissociation of ions takes place until the electricity passed into the electrolyte. So they are the assumption of Arrhenius theory of ionization. So what are the failures? And the failures for Arrhenius theory is it is generally for weak electrolyte, but it has some failures. So let's talk about that. So first failure is strong electrolyte dissociate completely. That's why there is no equilibrium in the strong electrolyte, but there might be equilibrium in the weak electrolyte. So in the second we have alpha, which is degree of dissociation. Yes, it may be obtained from conductivity measurement and colligative property in case of Arrhenius theory of ionization. Okay, but the value of degree of ionization obtained from these two methods are not applicable for what do you say, strong electrolyte. Okay, this agree well for weak electrolyte only. This value of degree of ionization agree well uh, about weak electrolyte only, but not for strong electrolyte. Okay, and the next is this is very important failure. In this failure we have interionic force between ions. So this Arrhenius theory of ionization does not talk anything about interionic force of force between ions, that is cation and anion, but in reality a certain force of attraction operates between the ion. Right, so that's why a new theory for strong electrolyte is needed, and we have the new theory which is called DebyeHuckel theory for strong electrolyte. Okay, so we also going to talk about the assumption of DebyeHuckel theory. Okay. Okay, so let's talk about DebyeHuckel theory for strong electrolyte. This is for strong electrolyte only, okay? This is not for weak electrolyte. And due to the failure of Arrhenius theory of ionization, DebyeHuckel theory for strong electrolyte is needed. And generally, DebyeHuckel theory for strong electrolyte talks about increase in conductance of strong electrolyte on dilution. So what is conductance? That is number of dissociated ion is directly proportional to conductance. Okay, that is, we have to increase the number of dissociated ion in a solution, so this will be performed by dilution. So on dilution, the number of molecule in a solution are far apart, and it has its space, more space for its mobility, and it obviously increases conductance. Okay, so here are the two effects, that is relaxation or asymmetric effect, and electrophoretic effect, which is very important for examination point of view. And first of all, talk about relaxation or asymmetric effect. So what is relaxation effect? So first of all, we have to understand that in an electrolytic solution there is a ionic atmosphere. Okay, and when until there is no electricity passed in the solution, this ionic atmosphere is symmetrical. Okay, and when the electric current is passed to the solution, the ionic atmosphere is formed like that, and the positively central ion move toward the anode, and sorry, cathode, and negatively charged ion, that is anion, move to the anode. Yes, and um, when the positively ion are out of atmosphere, it has to reveal its own ionic atmosphere again. Yes or no? Of own ionic atmosphere of oppositely charged around it, and the old ionic atmosphere, this is old ionic atmosphere, and this central ion has to build its own ionic atmosphere. Okay, so however, the destruction of old ionic atmosphere and the new ionic atmosphere, this does not take place instantaneously, but there is some time lag, which is called time of relaxation. And at the time of relaxation, the older ionic atmosphere pulls the central ion towards it, and this is called, and hence the moment of central ion, or the velocity of central ion retarded, which is called, this effect is called relaxation effect. Okay, and also during the moment of central ion, the ion that are present in front the central ion are left behind, so that the symmetry of ionic atmosphere, this symmetry of ionic atmosphere is what, destroyed. Therefore it is known as asymmetric effect. Symmetric to asymmetric, symmetric to asymmetric, that's why it is called asymmetric effect. Okay, so that is asymmetric effect. And how this effect will be overcome, it is by dilution. Okay, this theory talks about dilution. So here is another effect, which is electrophoretic effect. Okay, so what is electrophoretic effect? So we know that it has electrolytic solution has what, ionic atmosphere, and when electric current pass, it happen, what happened here is, the negatively charged ion, that means anion moves to anode, and cation move to cathode. Okay, and the flow of these ions are associated with the moment of central ion. Okay, and when they are moving, they are moving, the central ion is moving against the stream. Here central ion is moving in opposite direction and the other ion is moving in opposite direction. That's why the motion of ion is retarded. Okay, the motion of ion are retarded, so that effect is called electrophoretic effect. And here is also motion of ion retarded, but in the time of relaxation. Here there is no time of relaxation in electrophoretic effect. Okay, but there is time of relaxation in this asymmetric effect, or relaxation effect. Okay, so there are the two effects, and when the dilution is increased, the asymmetric effect and the electrophoretic effect decreases. That's why uh, it increases the conductance of what? Conductance of strong electrolyte. So that is the DebyeHuckel theory for a strong electrolyte. Okay, so we have a certain formula for DebyeHuckel's Onsager equation. I'm writing here. Okay, so this is very important. So this is the equation of DebyeHuckel Onsager equation. This is very important for a numerical point of view. Okay, so in DebyeHuckel theory of strong electrolyte, we are calculating the equivalent conductance, so that we are increasing the equivalent conductance. Okay, so this equivalent conductance at certain concentration is equal to equivalent conductance at infinite dilution, and 82.4, this is derived equation. So this is 82.4 divided by D means dielectric constant of solvent, T means absolute temperature, and this eta means viscosity of the solvent, and also dt, and this is equivalent conductance at infinite dilution, and this is the concentration of the solution. Okay, by using this formula, we can calculate the equivalent conductance of a solution in a certain concentration. So that is all for our video for today. And if you like this video, please hit the like button, subscribe button, and share to your friend as well. So thank you for watching this video. If you like this video, again you have to do like, subscribe, comment, and share. So have a nice day. Bye bye for now.